overview. Yes, thank you so much and a warm welcome. Thank you for giving me your attention. I would like to point out that we had some presentations building up on each other. Previous speaker Andreas Vater said there are a couple of brochures on OPC-UA, Global Production Language, and umati, which we put on the table here. But you can also come to our booth and talk to us directly. We have heard from Stefan Hoppe what OPC-UA can do. Andreas Fahrt told us what the whole thing means for machines and machine tools and engineering. And my part is to explain you how we bring it to the shop floor to practical use. And we start with a little film.
This is John. John's a plant manager. He wants to make his production more efficient. For this, he needs an overview of the data from his machines. John is not happy. He has various machines of different ages, from different manufacturers, and with different controllers. But it's not possible simply to connect them to his existing IT system. He needs to have interfaces programmed individually. That costs a lot of time and money. Moreover, some data is not even being recorded at present. What would make John happy is the possibility to connect any machine or component to his IT ecosystem quickly, simply, and without additional effort. And John is not alone. Many others share the same problem. To improve this situation and make things easier for their customers, machine manufacturers from all over the world have joined forces. Together, they have developed interfaces based on OPC-UA, the global production language. About 20 companion specifications for production equipment have already been published, including harmonized specifications such as OPC-UA for machinery. 30 more are under development. As a consequence, customers who use a range of different machines and technologies have to deal with different companion specifications. To make things easier, the implementation of these specifications needs to be harmonized. What's needed is a strong community which can exchange best practices, build trust, enable dialogue, and share information. Umati. Umati makes it all possible. Plug and play, no matter which manufacturer, no matter which machine. And so John can now finally connect all his machines to his IT system, easily, securely, and seamlessly. It's now easy for John to use and analyze all the data, gaining access to important information such as machine status, errors, and key performance indicators. Increases the efficiency of his production significantly, saving him time and money. And because umati is a global initiative that is still developing, it is guaranteed to keep pace with requirements as they evolve. John is excited. He's ready for the future. Umati, a community of strong partners connecting the world of machinery. Stay tuned and get connected online.
So, es kann jetzt sein, dass ich einige Dinge auch wieder.
Right, it might be that a couple of things are going to be repeated, things that the previous speaker said, but what we have to see is we come from the following situation. In particular, in production, each and every company does not only have a data ecosystem, but also a machine ecosystem. Various machines, various types, various years of construction, different controls, and each and every manufacturer will buy exactly that machine that will help to produce a certain product. And it's of secondary interest what kind of control it has and what kind of interface they want to earn money with it. And every company has its own data ecosystem. So you won't buy a machine because of the interface. Rather, you will adapt the machine interface to the existing ecosystem. As of today, fortunately, what happens is that the machines do not necessarily understand each other. Siemens controls will be able to talk to Siemens, but Fanuc or Beckhoff might have a problem with the others. And the solution for this problem is to be able to speak the same language, so you need standardization Stefan Hoffe brought a nice example as to how standardization can put into practice in the tobacco industry. It's user-driven. Big producers of cigarettes and smoking equipment, of which there are few worldwide groups, they came together and said, look, we want to clean up our act. We prescribe an OPC-UA interface to our suppliers. So some few tell their suppliers, of whom there are more but not as many, we prescribe to you how the interface looks like. If you walk through EMO, which shows production ecosystems, then you see that diversity is even bigger than originally imagined. And the question is, how can you bring these specifications into an area and bring it into play where there are no dominating player? Then you have to create standards. Standards are specific to the various technologies, and at the end of the day, people have to explain the story and tell people that it works together. The one thing is to explain the story, and the other thing is to prove that it works together, which is why we have the 3 OPC-UA as the standardization element, umati as the initiative to bring it all into industrial use in such a way that a smaller, medium-sized company understands it. Let me start with the first part of the solution. Some people stayed seated, so you have heard about it. OPC-UA offers a wonderful framework to specify how assets, how devices in automation technology can talk to each other. On top, you have individualized setups, dictionaries or companion specifications, and the whole thing creates something which is called semantic interoperability. Machines are talking to each other. Now there are specifications for robots, for machine tools, for plastics machines, etc. They're all individual and they do not necessarily have an overarching understanding. So yes, we can talk to each other. We have a global production language, okay. About 57 standards are being developed. 24 are available. You can get them from OPC-UA or VDMA, but that does not mean that you can buy the machines that have that implemented. Because standardization requires technology to become ready, and then technology needs to know how to implement the standard, and it doesn't necessarily mean that all of them can talk to each other. So it's not enough to have standards, not enough to have one standard. It's not even enough if you have 50 of them. You need to make them compatible among each other. Not compatible in the sense that OPC-UA would not be compatible, but compatible in that it is implemented across the board. I brought along 2 success stories where you can think about how did they come into the market. Take USB. Today you don't buy a device that doesn't have a USB port. Now I ask the typical question, who invented it? It weren't the Swiss, it were the Americans. Very small companies, Microsoft, Intel, Compaq, and driven by Microsoft. Microsoft said, well, we see that users want to connect more and more devices to their users. Older ones knows that with serial and parallel drivers that had to be downloaded. They wanted to realize plug and play, and since Microsoft was behind it right from the beginning, they had 70% of the market share. Now, if I move that to mechanical engineering and to machine tools, there's no individual player who would do that and have 70% market share. Maybe you have one that has 10 or 15, another one has 50 or 60 in a certain industry, but not everywhere. The second example, when you buy a laptop computer and you have this small logo Intel inside, then you know Windows and the applications that I want to use will most likely be running. So it's a promise to the user, look for this label, and when you see this label, you can assume that the software, people who developed software for you, they've done it so that it will be up and running on this device. So two questions come up. How can OPC UA become the USB flash drive for machine building industries? And the second question, which kind of performance promise can we derive from this? If we go one step further, we have a framework for standardization. We have various partial standards, and Andreas Farr has explained it. We are starting to harmonize it. In basic technology, in OPC UA, we start to harmonize in basic specifications for machine tools, because each and every machine has a type label. Type label says manufacturer, year of building, serial number, and other things. It doesn't matter which machine it is. This label should be the same. And there are some other building blocks when it comes to result transfer, job transfer, how certain data are transferred on a certain job, irrespective of what the machine is doing. It could be energy management, because for each and every machine you have to do energy monitoring. So harmonizing part 1, let's continuously expand the standard down there so that it's compatible to all of the machines. But if it's no longer suitable for machines, you have a kind of modular system. You have the basis, you have bigger parts like machine tools, then on top of that you would have forming, metal forming, etc. And you can always pick out what you need for your specific area of application. But still something is missing. We have standardized now, everything is good. Working groups create lots of papers. In case of OPC UA, the good thing is you only create paper. At the end of the day, they actually have test implementations that work, but then it's not on the market. Go over the trade fair. Lots of manufacturers will tell you they have a great interface, and if you ask them, in how far is that compatible with the greatest interface of your neighbor, and they'll probably say nothing to that. So what do we have to do? We have to take these lots of machine manufacturers that have an even bigger number of customers and form a kind of community out of them, so that we can talk about how we move forward together, how we can learn how to implement everything effectively, and how to create joint visibility. You see umati here at EMO. This year you were able to see umati at Automatica Trade Fair in Munich, which was about handling robotic vision inspection. You were able to see umati last year at CAR for plastics and rubber machines. You were able to see it at Ligna for woodworking machinery. All of these are individual industries. On a trade fair, you have the specific ecosystem, but the overarching story is no matter what kind of application we have, we as machine manufacturers delivering in individual industries will see to it that all the applications work. This is a level of stress that we don't want to give to you, the implementation guys, or to the customer. So you don't need to develop interface number 1000. You should be able to say there's something that works, that's good, I can simply take it and work with what I want to work, namely build good machines. Or to put it differently, what does it need? Well, somehow we need to tell the market that this does exist only because you've written a standard, only because there is a DIN or ISO, whatever. No one will know it, no one will use it. We create a kind of global community and we need to implement it. Let's talk about the first two, the marketing aspect of things. One thing is important. OPC UA is great, but the people who decide on purchasing, the purchasing manager or a production head who need to decide to buy a new machine, they are not interested in whether it contains OPC UA or whatever. They are interested into whether it helps to do my job, whether it fits to my use case, and it should not be communicated in a technical statement. You should be given statements that can be understood by everyone. So it's not tech guys talking to tech guys. It's people who at the end of the day have to earn money with it, talk to people who will earn money with it and how to improve matters, how to become better. And the second thing is we have to do this at a global scale. If you look around EMO is one of the trade fairs with the biggest share of exhibitors from abroad in Germany. I think we have a share of 70%. Production machine is globalized. 60% of all the machine tools that we buy in Germany come from abroad. 60% of all the machine tools that we build in Germany go to other countries. So it doesn't make any sense at all to say we invented the German standard, because then latest our esteemed manufacturers from Japan tell me what is there in for me, because I'm from Japan and not from Germany. So you have to be able to create a worldwide approach. This was one of the reasons for umati to say, well, at the moment it's the Germans, it's VDMA behind it, it's the Germans there, VDA, but you can all come into this, no matter whether you are organized in a German association, doesn't matter in which country you are. Open interfaces will help us to stay on the market and be competitive, and if you support that idea, then please, by all means, come on board. It's a change of paradigm. It's global, multilateral, multinational, integrating everyone who shares this idea. And then you come to this idea, which we've seen in the film. With 50 standards, we come to millions of users worldwide with lots of different problems, and at some point we have to bring them at a common table. We have about 320 partners now. We've been working in Umati Matters for about 5 years, and the promising thing is that it's still a German show, half of it, but the other half is completely non-German. And when you go into technology, you see Switzerland, Italy, Japan in production technology, in metalworking, production technology, in machines and factories, three-quarters. You have the big technology nations that are joined ranks. China has a bit of a special role because internally they're doing something specific. It's called NC Link and comes from machine tools. And sometimes China does things because they want to do things, but we are connected to them. So they are in a position to bring in data towards OPC UA system and to receive data, but the Chinese companies are not members. And of the ones you see, 80% are industrial members. So it's an initiative for the industry and with the industry. And here we have the industries that we are representing. We start with general mechanical engineering. We have machine tools, measuring technology, robotics, imaging, woodworking, plastics, surface technology, laser systems. Additive manufacturing came in. So it's really bringing in lots of different industries. And I'll show you later that this is not just me giving you words, it actually works. But let me ask who buys it, which is why we have a picture here. If a sales guy meets a purchasing manager and is supposed to talk about whether OPC UA is the next big thing, how will they be able to talk to each other? Well, they won't, because no one will read an OPC UA specification. They will always have to rely on their staff telling them, yes, it works, it's the right thing. But if you come to an ecosystem where your most important suppliers are in and also important customers saying, well, if you can believe in the umati label, you have one concern less. It will definitely work with each other. So for them, it's a massive help. They will be rest assured that they have a technology that not just an individual salesperson wants to sell them, but there is a movement behind it for the industry, with the industry, which makes some decisions simpler. And you can break that down to various jobs. So the purchasing manager of an automotive manufacturer has different concerns than the owner of a job shop that in the evening needs to do the entire machine hookup themselves. And you have to talk to people and tell them what is doable in the industry that they work in. You have to provide them with the communication. It's not enough for machine tools communicate to machine tools and robots to robots. It's an entire system. Let me come to the third item, that's implementation. And you have to give proof of the data exchange, and digitalization lives of people trusting it. If you can't rely on your data being available adequately, if you can't rely on that the right things are being done with the data at the end, then you will not want to do it. And maybe you just have to give a prototype and show it, which means we built an ecosystem which is called umati Demonstrator. It is accessible under umati.app, quite a number of machine streams in data, and you can see, right, now let me take a look at it. So robot is doing something, machine is doing something, maybe an additive manufacturing machine does something, and the data end up in the same ecosystem. They are usable the same way, no matter which machine it comes from. We built an infrastructure today. It has MQTT as a communication standard. There is an easy-to-understand dashboard, and by the way, this is not a product that you can buy off the shelf. But since we developed a demonstrator dashboard, we moved our knowledge into open source. And if you as a company wanted to start tomorrow to do something, you can simply use what we have done and what we brought in open source, and you can start experimenting with it. So for software guys, just try look up umati and find out what kind of resources are there. Of course, you have to have a secure application. That's quite clear when you walk around the trade fair. About 60 to 70 machines are connected live, and you can try it out. So let's come to our booth. We have various machines that carry that label and a QR code. If you scan it, you'll automatically come to a page on the umati website and can see live what the machine is doing and how it could look like in the application. And if you want to go on umati.app or scan the QR code or come to our booth, you can't destroy anything. You can just play around with it. And the important message is it works. And if it works in such an environment like the trade fair here, and we went to the United States, Japan, Korea, and other countries, then it's relatively certain that it will work in the protected environment of a company. Activities, well, we are active worldwide, and if you see umati, you don't see a robot manufacturer or a machine tool manufacturer. You see an initiative with the same look and feel, with the same story, with different approaches depending on the target industry, but at the end there is a joint circle, and that is umati at EMO. We have 3 pieces of news that I would like to report to you. Number 1, at the moment there is a certain trend. Umati makes data available. Umati is not here to tell you what you are supposed to do with the data, what you can do with the data, but we know that data exchange is really a hot issue. In a data ecosystem, we have to be in a position to exchange data in such a way that we can be certain that they're not used against us. Take the personal area, take health data that are interchanged with an insurance, or in B2B data that end up at the competitors and enable competitors to be better in the competition. So the idea is data end up somewhere. Every company has a data space, has a data ecosystem, and when you want to exchange data, these data spaces need to come together somehow. Talk about federated data spaces. I think this is the multiverse of data spaces. What is important is that there are mechanisms how you can make available your data to your customer or to your supplier, and that they work with it, and that you have mechanisms that the levels of trust are kept to, that they can only use data for the purpose you want them to be used. There is a big initiative. It started with industrial data spaces in Germany. There is an initiative called Manufacturing X. Worldwide, there are initiatives for worldwide global safe spaces. We are involved with umati. That's the next step for machine tools, for mechanical engineering. Let's show how you can implement such a data space as a prototype and what you can do with it. The next topic that is fairly well known to some people is the administration shell or asset administration shell. It has been mentioned various times. The first asset administration shells accompany the product over the entire life cycle, and at various positions, data will be moved into the digital twin. If it's about shop floor data, we say, well, you don't need to reinvent it. You can take OPC-UA for it. So together with EDTA, as the carrier of the asset administration shell, we build a demonstrator as to how data can be filled into an administration shell that are made available through OPC-UA. The third topic, MT-Connect, is a bit of an older one. It's an initiative for machine tools. It took a while to move forward together, but now we have found a way. So since this EMO, we are working with each other. We have to define what it means exactly and how we want to implement it. But there again, it's clear at the end we need to cooperate globally, and we need to be able to connect to each other to move into the future. And I would like to end with this picture. We've got 3 elements for open flow of data in production. You need a good framework to standardize. You need a community that develops standard, and at the end you need someone that makes it usable and turns it into practical implementations. And that's what we want to do together. I'm happy for your attention. You can ask questions now, or you can come to our booth right opposite this, and I and Mr. Hopp and Mr. Fahrt will be available for questions. Thank you.